All right, everyone, thank you for watching this video. So here I'm gonna talk about new stuff that has been pushed to Karl over the last 2 weeks. We've got a lot of new stuff. Basically, this is very good. Like we've got a playground now. We've got an integration with JupyterLab notebooks. We've got an application which is called Karl Sheet, and lets you use Karl syntax inside as formula inside kind of a spreadsheet application. And we've got a REPL where you can try all the features of Karl. And this has been contributing very massively by Nicolas. So thank you so much for this for all this stuff. It's great. Basically, so we've got a release which was pushed today, 060, and I'm gonna show a couple of features of first the playground. And so when you load the playground, you can try Karl today. Basically, it's hosted, and it executes this simple Karl program. And in this program, you can already use you can use sleep, and you can use channel and spawn a task, spawn a function and get a task and read from a channel, and that gives you this. So there's a list of example here, list of program example to show some features. This recover operator. So I'm going to talk a little bit about this. So you've got this operator basically. So you can use that after any expression and think of it like a try catch finally, but as expression basically. So this after this operator, you can have a block basically, and inside this block, you will have access to an implicit object error that describes the error. And so here, in that case, we try to access a retry count property which doesn't exist on this object. So this is an error, like it gives you a missing property retry count, and then you can recover from that error. So in Karl, the last expression in a block is what is returned. There's no return keyword. So retries become 0, and here retries becomes -1 because we cannot parse the string as integer, so we enter the recover block as well. And so you can use that on any expression basically, any expression that you write. If it's raising a runtime error, then you will enter the recover block, and this also works with task, basically with worker task. When you spawn a job and you're executing some code in the background, you can also recover inside the task, but also from the task at the higher level. So this works. So I really like this example. Very simple, but tells you a lot of what you can do with Karl. And by the way, I just like the syntax. But it's a syntax that I designed, so I must love it, obviously. So this ampersand operator is what you put in front of a call expression, and so that returns a task which will execute in the background. So here we simply sleep for 100 milliseconds and then return the integer 20. Log, base is a task, right? So if I'm executing this and put the auto run mode, so base is a task. And here what we are going to do is we are calling the then construct on this task. And this is not like in Node.js, where in Node.js I think it resolves basically. So it's you enter this, and at this point you access the value. In Karl, it's not the way it works. So this is just returning another task. So this is a task, and dot then with this function inside it returns another task, which can then be chained again another time. And this doesn't give you a value until you call wait. So the wait keywords is really the way you access the result of the computation. And task in Karl are first-class objects. So it means that basically I can pass a task to a function. So I could define a resolve function, t, and here I could do wait t, and then instead of doing out, I'm gonna resolve out. Oh, sorry. So yeah, you get the same thing. So you can just pass the task to a function and wait it from here. So this ampersand operator, which is the concurrency operator, it spawns a task in the background. It spawns computation in the background and return a task handler, which you can wait, which you can cancel, which you can do a number of things with that. And as you can see, it works with a simple call expression. So you can do this, right, to spawn fn computation in the background, but you can also do this. Here, it's kind of a join. It's kind of a wait group. It spawns multiple computation, and then you are joining. You are waiting for all the computation to have result, to access the result. So you've got a concise syntax that lets you do a couple of things in Karl. Another example that I like is, I like all of those examples, but so here we start with a channel. We have a producer-consumer example. So a producer is writing to this channel, alpha, beta, and gamma, and at the end it says like the channel is not gonna send anything more. And here we are using for loop construct and are reading from the channel every value. And when we are reading from a channel, it gives you the value and a boolean that tells you if the channel is closed or not. And when the channel is closed, then we break and we return hack. And actually what we can do here is, it's redundant. We can just break, because when we break, it will enter the then block. When we break with a value, it returns that the value becomes the loop value immediately. But here it's redundant. It's just returning the same thing basically. So we can break it, enter the then block, and in the then block, we return this accumulator list, which is constructed by all the values that we receive, we put them in the list. And actually, let me modify a little bit this example just to show. So here, what we're going to do is maybe put that to square, and here we're going to take the sum of that list, right? And so you can verify that it will give this result. Okay, what else do we have? You already seen that. We've got map and set. We've got match with guards here. Like I was saying, like for the for construct is an expression in Karl, so it returns the last expression in the then block, and then is a block, so you can do many things in here, including like calling function and transforming the result further. You have in Karl you have the dot syntax, which lets you define list. you have an additional step argument which you can use. Oh, yes, I need to. If I increase the step, basically, we don't have enough element in this list, and then we cannot take that much, so we get a slice bound out of range, obviously. Now if I'm increasing this, yeah. So you can use this the dot syntax to basically create a list, and it works on chars as well, right? You can do this, and it gives you like a slice of and you can use this syntax as well on string to create a new slice of a string. So that's it. This is just showing function. Okay, so that's for the playground, and the playground is called experimental because basically this is not a backend that we have here. We compiled the Karl interpreter into WebAssembly, and we have got a static WebAssembly file which is loaded in the browser, and basically like that's what we use to evaluate the Karl program in the browser. So it's available today. You can try this as this URL. But, yeah, just remind yourself that it's experimental because it's not exactly like the Karl interpreter. So all the tests that we have on the Karl interpreter, there's we discover like a few bugs. So it's not bug free for sure. But yeah, it lets you try Karl today in your browser, so feel free to use it. So this is a very good example of integration of Karl in JupyterLab notebook. So I'm going to execute this code here, and it's very simple code. Like it defines a list. Otherwise, this list is used as a place as a recovery value in case this URL doesn't give you the same thing. But yeah, we decode the JSON given by this URL. We take the top 6 user, and then we format the data as a HTML table and display it. So you can use Karl in your notebook today. So we've developed a kernel for JupyterLab. You find all of that in the repository. And yeah, it's here, and there's instruction on how to set that up, etc. And basically, you can convert from the Karl notebooks have extension .knb, and so knb is not directly executable in the Jupyter notebook, but you have a convert command, so you can convert back and forth between IPYNB and KNB, and yeah, that's it. We've got this other thing, crazy application. It's called Karl, the Spreadsheet, and lets you use Karl, the Karl syntax in the Spreadsheet app as formulas, basically. So here we are just saying like if B5 is truthy, which is the case here, but if I was changing that to 0, it would be falsy. And yeah, you've got an if-else expression inside the spreadsheet cell, and here we define like a function, and so you can reference that function. So in this cell, you've got a function. B7 is a function. You call that function, but that function, by calling referencing the cell in question that contains the function definition, and then you pass the value. So you call that function basically, and you get the result that you expect. And you can do a number of things. Basically you can do what you think you would be able to do. It works very well. It's very nice. And finally, we've got Karl Loom, which is a REPL. And with this, you can You can try all the features of Karl and basically all the things that you cannot try very quickly in the playground, like this obviously doesn't support read file, built-ins that let you access system calls, etc. But you can do that in the Karl Loom REPL. So for example, if I'm writing environment, I've got this function that gives me all the environment variable in the systems. Can do yeah, user yeah, blah blah blah. You can do all those things in the Karl Loom REPL. Yeah, that's it for me. Hope you enjoyed this video and gives you the motivation to maybe try Karl and see if it's something that you like or not. Thank you very much. Bye bye.